Hello all, welcome back to the problem solving session on the topic linear support vector machine. So in the given dataset, we have 4 positively labeled data points and 4 negatively labeled data points. The positively labeled data points namely 2 2, 4 2, 5 3, 3 4, and negatively labeled data points are 1 minus 1, 2 0, 0 1 and 1 1 respectively. And if you see in 2D view, the positively labeled data points are the orange points and negatively labeled data points are the there it is, yeah, the negatively labeled data points are the blue points, right? Now in this case we need to draw a hyperplane. That is our objective. Hyperplane that separates these two positively labeled data points and negatively labeled data points. So in this case, by looking at this data points itself, we can say it is a linear support vector machine, since a linear line can able to separate these two classes, right? Fine. So if you draw a hyperplane by crossing these three points, right, we can able to draw a hyperplane. So the points, the data points that lie near to the hyperplane are S1, S2 and S3. These three vectors will act as a support vectors in this problem. So the values of S1 are 1 0 and the data points of S2 are 2 0 and S3 is 2 2. And with the bias 1, we are going to add for all those three support vectors. So S1 becomes 1 1 and it will becomes as S1 cap, which is equal to 1 1 1. And for S2 is 2 0, then S2 cap will become 2 0 1. S3 is 2 2, then S3 cap will become 2 2 1. And the equation, right, it is to calculate the weight vector. The equation in this problem, you have two vectors related to negative hyperplane and one vector related to positive hyperplane in both ways, right? So alpha 1 S1 cap into S1 cap plus alpha 2 S2 cap into S1 cap plus alpha 3 into S3 cap into S1 cap, which is equal to minus 1. In this case, you have two values on negative side of hyperplane and one value on positive side of hyperplane. So that's why we have given minus 1 and plus 1 over here. And substitute the values of S1 cap, S2 cap and S3 cap. We will get the term like this, right? And next step we are going to take a dot conversion rule over here. So if you do that, it will become alpha 1 into 1 plus 1 plus 1 plus alpha 2 into 2 plus 0 plus 1 plus alpha 3 into 2 plus 1, which is equal to minus 1. And some may ask, so why don't you use plus 1 here and minus 1 for remaining two cases? Yes, that is also possible. So there won't be much change in the result. You can try and see. So alpha 1, which is equal to 2 plus 0 plus 1 plus alpha 2 equal to 4 plus 0 plus 1 plus alpha 3 equal to 4 plus 0 plus 1, which is equal to minus 1. Same way for equation number 3. If you simplify this, you will get 3 alpha 1 plus 3 alpha 2 plus 5 alpha 3, which is equal to minus 1, and 3 alpha 1 plus 5 alpha 2 plus 5 alpha 3, which is equal to minus 1, and the third equation becomes 5 alpha 1 plus 5 alpha 2 plus 9 alpha 3, which is equal to plus 1. By linear equation, if you solve this, you will get three values for alpha 1, alpha 2, alpha 3, namely minus 7, 0 and 4 respectively. Fine. And in order to calculate the weight vector W vector, which is equal to sum of I, in this case I value tends from 1 to 3, right? Alpha I, you have three variables, and Si cap you have three support vectors, right? So if you substitute the values of alpha 1, it's minus 7, and S1 is 1 1 1 plus alpha 2 is 0, S2 is 2 0 1 plus alpha 3 is 4 and S3 is 2 2 1. If you simplify this, you will get minus 7 minus 7 minus 7 plus here it is 0 plus 8 plus 8 plus 4. So if you sum these two vectors, you will get 1 1 and minus 3. So the above the vectors are augmented with a bias, as in this case the hyperplane equation is given by y equal to ws plus b. In this case the value of b is minus 3 and the weight vectors are 1 and 1. Fine. So here you will get substitute in this equation SVM decision boundary, that is w1 x1 plus w2 x2 plus b, which is equal to 0. So w1 and w2 are 1 1, substitute in this equation and b is minus 3. So you will get the equation as x1 plus x2, which is equal to 3. So if you take x2 which is equal to 3 minus x1, the coefficient of x1 is nothing but minus 1. That minus 1 is nothing but your slope. So while you're drawing your hyperplane, the slope should be minus 1. We can check it out. So in this case, we substitute x1 equal to 0. So what is the value of x2? We substitute x1 equal to 0, x2 equal to 3. So the values are the y axis is 0 comma 3, and if you substitute x1 equal to 3, so you will get x2 equal to 0. This is the point that it crosses in x axis. It is 3 comma 0, right? In y axis it crosses at 0 comma 3, and in x axis it crosses at 3 comma 0. See here, and the hyperplane that crosses at 0 comma 3 and 3 comma 0, and you need to draw a 45-degree line that crosses these 2 points respectively, and this hyperplane makes a boundary between positive class and negative classes. In this case, as I said earlier, there are 2 supporting vectors on negative side and 1 supporting vector on positive side. Thank you. We'll see you in another video.